All right, let's talk about section 1.2, so observational studies versus designed experiments. So an observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variables. That is, in an observational study, the researcher observes the behavior of the individuals in the study without trying to influence the outcome of the study. So we want to talk about a designed experiment. If a researcher assigns the individuals in a study to a certain group, intentionally changes the value of an explanatory variable, and then records the value of the response variable for each group, the researcher is conducting a designed experiment. So examples of designed experiments might be having two groups of people, one which might take a particular medicine and one which may not, and where they would study if the medicine was having the desired effect or not. An observational study could be anything from sitting and watching people do things or animals or whatever, or even interviewing people. So just quickly grabbing somebody and asking them what they had for lunch or something like that. So observational studies are very useful tools for determining whether there is a relationship between two variables, but it requires a designed experiment to isolate the cause of the relation. So let's talk about that briefly. So to be able to say that one thing causes another, you have to have a designed experiment. So you have to have controlled environments or situations. You have to have multiple groups. So you've got the control group and then the experimental group. Versus an observational study where you're looking at different things. So one of the best examples of this is smoking and cancer. So for so many years, they could not actually say that smoking caused cancer. They could only say that there was a very strong relationship between people who smoked and the number of people getting lung cancer. But because that was an observational study, they couldn't say that it caused it. And then having a designed experiment where you take people and you force some of them to smoke and some of them not to wouldn't be very ethical, especially whenever you think the outcome is going to be cancer. So keep in mind, if you're saying that something is caused by something else, it has to be because of the results of a designed experiment. So confounding in a study occurs when the effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and a response variable may be due to some other variable or variables not accounted for in the study. And so if you have an explanatory variable that was not considered in the study, but it affects the value of the response variable in the study, then that's going to be a lurking variable. So also, lurking variables are typically related to explanatory variables considered in the study. So to also go into explanatory variables and response variables, so an explanatory variable with the smoking, it would be if somebody smoked or not would be the explanatory variable, and the response variable would be if they got cancer or not. So the explanatory variable is the first part, and the response is the outcome. All right, let's look at a few examples and determine if these are designed studies or observational studies. So a survey is conducted asking 400 people, do you prefer Coke or Pepsi? So this is going to be observational. So they're just going through and they're taking people and asking them for an opinion. So they're not having to design an experiment. They're not having to put people into different groups, things like that. For B, while shopping, 200 people are asked to perform a taste test in which they drink from two unmarked cups. They are then asked which drink they prefer. Now this is sounding closer to a designed experiment, but if we look back up here, it's telling us that they have to assign the individuals in a study to a certain group. So they intentionally change the value of an explanatory variable in the two groups. So with these 200 people, nothing is different between 100 of them and the other 100 of them. So this is just asking for an opinion from 200 people. So this is going to be observational. For C, 60 patients with carpal tunnel syndrome are randomly divided into two groups. One group is treated weekly with both acupuncture and an exercise regime. The other is treated weekly with the exact same exercise regime, but no acupuncture. After 1 year, both groups are questioned about the pain of the carpal tunnel syndrome. So this one is very clearly a designed experiment. So they have the two groups. The two groups are being treated differently, and then they're seeing the outcome. For D, 7th grade students are randomly divided into two groups. One group is taught math using traditional techniques. The other is taught math using a reform method. After 1 year, each group is given an achievement test to compare its proficiency with that of the other. Again, we've divided people into two groups. They're being treated differently, so the way that they are taught math, and then they're looking at the result. So again, this one is also designed. So a designed experiment. For E, conservation agents netted 250 largemouth bass in a lake and determined how many were carrying parasites. Again, this is just observational. There are no separation of groups, and there's not treatment of two different groups. And for F, a poll is conducted in which 500 people are asked whom they plan to vote for in the upcoming election. Again, they're not separated into groups, they're not treating the groups differently, so this is just observational. Okay, let's talk about different types of observational studies. So there are cross-sectional studies. So these are observational studies that collect information about individuals at a specific point in time or over a very short period of time. There are case control studies. These studies are retrospective, meaning that they require individuals to look back in time or require the researcher to look at existing records and control case studies. Individuals that have a certain characteristic are matched with those that do not. Cohort studies. A cohort study first identifies a group of individuals to participate in the study, so that's the cohort, and then the cohort is observed over a period of time, sometimes a really long period of time, and then over this period of time, characteristics about the individuals are recorded, and some individuals in the study will be exposed to certain factors unintentionally, and others will not. At the end of the study, the value of the response variable is recorded for the individuals. And then collecting data, a census is a list of all individuals in a population along with certain characteristics of each individual. So we talk about the United States Census, and in theory, that is every person in the United States as well as the data on each of those people. We realize that's not completely accurate because not everybody has an address. So let's look at a few examples. So researcher Penny Gordon Larson and her associate wanted to determine whether young couples who marry or cohabitate are more likely to gain weight than those who stay single. The researchers followed 8,000 men and women from 1995 to 2002. As they matured from the teens to young adults, when the study began, none of the participants was married or living with a romantic partner. By 2002, 14% of the participants were married and 16% were living with a romantic partner. At the end of the study, married or cohabitating women gained, on average, 9 pounds more than single women, and married or cohabitating men gained, on average, 6 pounds more than single men. So why is this an observational study, and what kind is it? So again, this is an observational study because these people are not being split into two groups and being intentionally treated differently. So they're simply taking these people and looking at what happens. And the type, we're getting a group of people and then following through time. So this is going to be a cohort. What is the response variable in the study, and what is the explanatory variable? So they're trying to see if being married or cohabitating makes somebody more likely to gain weight. So the response variable that they're looking at is gaining weight. Or weight change, but we'll keep it as gaining weight. And the explanatory, so the reason that the weight gain may happen, is going to be if they're living with a significant other. So living with a romantic partner. And then for C, identify some potential lurking variables in this study. Well, it could be that the people who were living together had more bills. So maybe the people, both parties in that couple were working more or had higher stress lives. They could have also had a genetic predisposition. It could have had to do with other things, such as their exercise habits. And this list can go on forever. And so for D, does getting married or cohabitating cause one to gain weight? And explain that. So for D, it's asking, does getting married cause this to happen? Well, no, we can't say it causes it to happen. This is an observational study. So with an observational study, you can say that there's a correlation, so there's a relationship there, but you can't say that getting married actually causes somebody to gain weight. So no, there's a relationship, but we cannot determine a cause.